Okay, so let's start today's session. Today we will talk about the electronics gate topic, and as previously I told about that, like most of the gate questions were already discussed, so we are going to shift to the net and as well as the TIFR questions. Some of the student asked in the last class that we will talk about the TIFR question also. But in that class, I just only focus on the net question, but maybe in the next topic I will go to the TIFR also. So let's start. Okay, so this is the first question. So gate topic electronics, and I have taken the question from NET 2018 December. Session, and the question is this one. Question is 43 number question, and it is showing that the truth table below gives the value y, a, b, c, where a, b, and c are binary variables. The output y can be represented by which one? Okay, so this is the question. This is a very simple question. I think all of you should know the answer. So here you can see, if I just write here, if I just see here, you can see a, b, c is there, and the y output y is given here. So in that table, what will be the value of the output? So how to do that? Obviously, at the very first, we have to choose the which one at the 1 as an output. So which one is 1? This one, this one, this one, and this one, right? So if I just see that, I am not going to write the full expression in the next page. I am just going to do the only one case. So a, b, c. If I write here a, b, c, y. 1 1 1 1. In that case, there are 4 ones coming. So a 0 0 0 0 1 1. Okay. 0 0 0. Sorry. Let me write it properly. Someone has already written the answer, I think. Okay, I will check that one. But let me first write that one. 1 1 1 1. 0 0 0. Then 0 1 1 1 0 0 0 1 1 1 0 0, and then 1 1 1. Okay, so now what will be the answer here? The output will be what? So you can see here, if I just do here 1, then it will be like a bar, b bar, c bar from the very first one. Now from the second one, a bar, b, c, right? The third one, a, b bar, c bar. The fourth one, a, b, c. That is the output. So let's check that one. A bar, b bar, c bar, a bar, b, c, a, b bar, c bar, a, b, c. This one. You can see here, a bar, b bar, c bar, a bar, b, c, a, b bar, c bar, a, b, c. So that means our B will be the correct one. Now let me check what is there in chat box. Okay, very good. So this is the correct answer. Okay, so I hope you understand that for that question, what we need to calculate at the very first, we need to find out which one is the one for output, and corresponding that one, we will write the A, B, C combination. So if it is 1, then it will be A bar, B bar, C bar. Similarly, if it is 1, then A bar, B, C, like that. Okay. So I think it's done. So we'll go to the next question. If you have any doubt, you can ask me. So, okay, let's move to the next question. Next question is from NET 2017 June. So this is the question. Let's see the question here. Question number is 65. Both the data points and a linear feed to the current versus voltage of a resistor are shown in the graph below. Okay. So here you can see 0, 1, 0, 25, I ampere, V in volt. So it is a plot given here. Now, if the error in the slope is 1.255 into 10 to the power minus 3 ohm inverse, then the value of resistance is estimated from the graph is how much? So now, first of all, I can tell you one thing. In that option, what you can see? There is something, number, and there is something. So this is the principal value, this is the plus minus, means like there is some error, right? So the error will be this portion, the second portion will be the error, and the first portion will be the actual value, right? So first of in this case also you can see here, in this case also you can see. So first of all, I just want to tell you what will be the value of R here for the principal case. What will be the value of R? I am not talking about right now the error. Error will come in that second part. So what will be the R value here? Can you tell me? That is a very simple thing. Like we can see the plot, and from that plot we can see the R value.
25.
How much?
25.
Yes. So how to do that? Like obviously it is V by R, V by I, right? So V will be like 0 to 25 is there. So that's 25 minus 0 to 1 to 0. So by 1 to 0, that is 1. So what is 25? Now you can see that the options. This is 25, 25, 25. So obviously this will not be the correct answer. First of all, I just want to discard the A option. Now we will focus on the B, C and D option. Which one is the correct one? So what is there in B, C and D option? There is nothing but the difference in that error. So we have to calculate the how much error is there in the calculation of resistance. Okay. So how to do that? First of all, I was V by I equal to V by R, right? Now our R was what? 25. We have calculated. The principal value of R was 25. Now we just need to calculate the error in R. That we need to calculate. So how to do that? Okay, so first of all, the slope. Let me write here slope. Slope was, let's say, M. From that picture, it was I, it was V. So the slope will be nothing but V by I, right? The slope will be V by I. Or I by V. Can you tell me I by V or V by I? Y by X. That means it will be I by V. Right? I by V. Right. So, but our R was what? R was V by I. So that means can I write it like R equals to 1 by M? Obviously I can write. Okay? Now, in that question they are saying that the error in the slope is this much. So why I need to calculate the slope here? Because they have already given the error in M. They have given this one. So in terms of that one, we just want to calculate the error in R. Okay? So I have already know the relation R equals to 1 by M. Now, what will be the value of del R del M? Minus 1 by M square. Right? Now, we have to calculate error in R. So what will be the what will be the expression for that? The expression will be sigma R square. Let's say it will be del R del M whole square sigma M square, right? So where here you can see sigma M is already given. Sigma M is nothing but error in M. So sigma M is given. Del R del M we already know, that is minus 1 by M square. Now we can calculate the value of sigma R square, right? Okay. So sigma R square. If I write it sigma R square, then okay. So 1 by M square whole square into sigma M square. Now 1 by M square means it is m to the power 4 sigma M square. And from the very beginning we already have the relation that R equals to 1 by M. So that means m to the power 4 is like nothing but R to the power 4. Is it? Okay. So sigma R square can be written as R to the power 4 sigma M square. So sigma R will be what? Sigma R will be R square sigma M. Now sigma R is nothing but error in R. So R we know, R is 25 whole square into sigma M. Sigma M was I think 1.255 into 10 to the power minus 3. So 1.255 into 10 to the power minus 3. Right? So now we just need to calculate 25 square into, I am calculating here 25 square into 1.25 255 into 10 to the power minus 3. So the answer will be 0.7843. I mean, we don't need to calculate that much, but yeah, let me check the answer here. 0.78, right? We got the sigma r as 0.78. Now you can see here. Okay, so 0.78 means obviously we can write it like 0.8. Yes. So the correct answer will be B option, because 25 is there and the error is 0.8 plus minus 0.8. Do we have any question on that? I think it's clear. So for that, what we did in that question, first of all, we just calculate the principal value of R. The principal value of R will be 25. Now we need to calculate the error. So how to calculate the error? Error has an expression that sigma r square equals to del r del m whole square into sigma n square. Now del r del m we have already calculated as 1 by minus 1 by n square, and then that whole square, that is 1 by n to the power 4, and then sigma n square. Sigma n square was already given. So error in the slope we have just plotted that one, and then 1 by n to the power 4 into sigma n square, and 1 by n to the power 4 is nothing but r to the power 4 into sigma n square. So sigma r can be written as r square sigma n. Sigma r equal to r square sigma m. So sigma r will be error in r, and how to calculate? 25 square into 1.255 into 10 to the power minus 3. So if I calculate that one, then it is coming as 0.7843. So the answer will be total answer will be R 25 plus minus 0.7843. That is the answer. And we have calculated, we have checked that the answer is B. Okay. Okay. So we will go to the next question. Next question I have taken from GATE NET 2017 June question paper, and the question is the question is 45. See, this is also the very similar what we did in the previous question. So we can do that quickly also. The experimentally measured values of the variables x and y are 2 plus minus 0.05 and 3 plus minus 0.02 respectively. What is the error in the calculated value of z equals to 3y minus 2x from the measurements? Right? So what will be the answer here? There are 4 options. They have given x and y value as, okay, you can see here, this is nothing but, this is the principal value of x, and this is the nothing but the sigma x, and this is principal value of y, this is sigma y. So they are asking that what will be the value of sigma z, right? So we have to calculate. Can anyone tell how to? Okay, someone is there. Can anyone tell me what will be the expression for that sigma z? It is very similar whatever we did right now, that sigma z square. What will be the expression for sigma z square?
Del z del x whole square into sigma x.
Del z del x whole square sigma x square plus del z del y whole square sigma y square. Right? Now we have to just calculate simply del z del x, what will be the value, and then this whole square into sigma z square del z del y whole square sigma y square. That's it. So let's just do it quickly. Z equals to 3y minus 2x. Z equals to 3y minus 2x. So if I do del z del x, it will be minus 2. Del z del y 3. So sigma z square will be minus 2 whole square sigma x square plus 3 square sigma y square. Now come here 4 into sigma x square. Sigma x square is how much? Sigma x square you can see here 0.05 as sigma x. Okay, I am going to write here sigma x is 0.05. Sigma y was how much? 0.02. So 0.05 whole square plus 9 into 0.02 whole square. That will be sigma z square. Now sigma z will be total root of this one. Now let me just calculate this one. 0.05 whole square into 4 plus 0.02 square into 9 root over answer. Okay. So this is 0.0136. If I just calculate the root, then it will come as 0.116. Okay. So the sigma z is nearly 0.12. You can see here like 1.11, 0.116 means 0.12. And if I see the answer here, see the 0.12 is given here. So the answer will be 0.12. Okay. Okay. Actually, these are very similar questions, so that's why I just put it in a single frame so that it will be very much useful for all of you. That like whatever the error type questions will come, then we can definitely answer that one. So basically the main expression for that error calculation is like sigma z square or sigma x square or whatever. That should be the derivative of the dependencies into square into that dependencies error plus like that. Okay. Okay. So now going to the next question. That I have taken from GATE as CSIR NET June 2017 question paper. This is question number 64. This is a little bit different. Like it is totally on the electronics case. Digital case. In the figures below, X and Y are 1-bit inputs. The circuit which corresponds to a 1-bit comparator is how much? So which one? So 1-bit comparator means what? It is nothing but a comparator. Comparator gives us what? Comparator means, let's say I have X and Y. So okay, this is output. So let's say I am writing here 0 0. That means the output should blow at this point. If this condition I have given, then output should blow at this condition. If this, then it should go at this. Right? This is the comparator. Now we have to choose that which one is the correct option for comparator. I am giving the picture of this. I think you can see. Yes. So these 4 options are there. So which one is the correct one? We have to check that. How to calculate? How to check? First of all, okay. You can see here the output is given here. Right? This one, this one, this one, this. So let me write here at the very first only one condition. I am going to check only one randomly. Let's say I am writing here 1 0 randomly. If it is 1, then you know that if it is a NAND gate, a NOT gate. So NOT gate means it will come as 0. This 0 is coming here and it is AND gate, right? So whatever it will come, it will not see because the one input is 0. That means it will directly give us 0. Now you can see here, this is 0. This is not blowing up. Okay, now this 0, it will come as 0. This is also not blowing. But we have taken 1 0 condition. That means this should blow because x should be greater than y. As it is not blowing up, it is giving us 0 value. That means this whole option will not be the correct one. We will only check 1. We will not check 3 conditions differently. If one condition will blow up correctly, then it will be the correct one. Okay. Let's check C option. Just a minute. I just randomly take that one. Let's say 1 0. If it is 1, it is 0. If it is 0, it is 1 because it is not gate. Now this one is coming. There is also 1, right? So this one will come. Here 1 will come. Now you can see here it will blow because this is 1. X greater than y. And yes, obviously we have taken 1 x and x is greater than y. Just see the other 2 options also. Now see here it is 0. So if it is 0, then obviously it will come as 0 as an output. So that will not blow up. That is correct. Now this 0 is coming, this 1 is coming. It is XOR gate. NOR gate. So it will come as 0. Right? because 1 0 was there and NOR gate will give us 0. So that means you can see here, for this case it is 1, this one is 0, this one is 0. That means this option will be the correct one. You can check other options also, but each and every one will not give the correct one. Only C will give the correct one. That's why C is the correct answer for this case. So for that question, what we need to calculate? We just need to know what is the comparator circuit expression, Boolean expression. I have already written there. Just to check that one, we have to check only once at a time. Like let's say I am checking this one, this condition. This condition I am going to check for this circuit. If it is not blowing, then we will go to the next one. Then we will go to the next one. Then you can see that the C option will give the correct one. That's it. Okay. Okay. So we will move to the next question. Yes. Okay. So yeah. This question we have taken from NET 2016 December question paper. Okay, this is also a little bit different one. Let's see that. This is the question number 42. The IV characteristics of a device can be expressed as I equals to IS. By the way, till now, do you have any question? You can ask me. Okay. So if you have any question, then you can ask me, or otherwise we will go to the next question. This is the next question. Okay, I think there is no question. Fine. The IV characteristics of a device can be expressed as I equals to Is e to the power AV by T minus 1, where T is the temperature and A and Is are constants independent of T and V. Which one of the following plots is correct for a fixed applied voltage V? Right? And here basically you can see this is written as 1, but it should be log I. But yeah, fine, we can understand that is log I. So what will be the correct plot for this case? So basically you can see the plot is nothing but between the plot is between log I versus AV divided by T, right? Okay. And what is the expression given here? I equals to Is. If anyone already did that one, you can write in the chat box the answer also. No problem. Okay. There is one missing. This is D. Okay, fine. Okay, so I equals to Is e to the power. I am going to write that one. I equals to Is e to the power AV by T. Then what is there? Minus 1. Okay. So this is the case. This is the correct expression. Now what we will do? We will simply do the okay. First of all, we just need to write here a very simple expression. Let's say I am writing here x. AV by T equals to x, so that it will be very much useful for us to answer the question. I am going to write like that, right? Now, if let's say our AV by T is large. Large means with comparison to 1 we can neglect, with comparison to e to the power x we can neglect 1. So for simplicity I can write like that also, right? So I by Is, that will be e to the power x, then log of I by Ix, that will be x, that will be x, right? So I can write here log of I minus log of Is equals to x. Then log of I can be written as x plus log of Is. So x was what? AV by T plus log Is. Now you can see that our plot was nothing but log of I versus AV by T. That was our plot. So there is something, it is nothing but mx plus c. So if it is like that, our slope is 1, our x is this one, and c is log Is, right? So this is nothing but a straight line like thing, but there will be some value as c. So that will be here and then it will be like that. But yes, I have already taken one assumption here that e to the power x is very greater than 1, so that I can here write I equals to is e to the power x, right? So that means there will be some deviation from that straight line, but it will be little bit like that. It will increase and it will go upwards, and there will be some intercept. Now we have to just check that which one will be the correct option here. See, first of all, this one will not be there because there will be no decreasing function. You can see here that is like log of I equals to x plus log of is, and x is ab by t. So I can write here ab by t plus log is. Now you can see here there will be no decreasing function. Okay, that will not be the correct one. Now you can see here it is increasing, that is fine, but at some point it is coming down. It is also not correct. Here you can see it is coming, but at some point it is going as a saturated value, and you can also see that it is coming from the 0 value. There is no intercept, that is also not correct. But come here, you can see that there is some intercept here, and then it is coming like that. So the correct option will be D. And the intercept value is what? Intercept value is log of is. Okay. Okay. So this is the case. I think you understand. If you understand, we will go to the next question.
Log is negative. Is it?
Sorry?
How log is negative?
Log I is negative means, like, let's say like where it is, yeah, ab by t, let's say plus log of is. I don't know the value of log of is, na? So it may be possible that the log of is can be the minus, let's say minus 2. It is because we don't know all the values. These are the just numbers. They are just given some numbers, random numbers. So we don't know about the values also. So log of I can be minus 2, na? No problem, because I will be what? 10 to the power minus 2. That you can have, right? So we don't know the value of this. We don't know the value of these things. So like we just need to see the nature. That's it. We just need to see the nature. So obviously it can be possible. That is not a big problem. We just see that okay, there is intercept, and this intercept should be shown in any type of plot. And where it is showing, in this plot it is showing, and also it is showing the increasing function. That's why we have concluded that the option D is the correct one. Okay. Okay. So now we will go to the next question. Next question I have taken from June NET 2016 question paper, and this is the question. Yes, that is a little bit interesting question. See the question. The dependence of current I on the voltage V of a certain device is given by I equals to I0 1 minus V by V0 whole square, where I0 and V0 are constants. In an experiment, the current I is measured as the voltage V applied across the device is increased. The parameters V0 and I root over I0 can be graphically determined as there are 4 options. Okay. So the meaning of the question is what? Basically you can see here there is one IV relation. I equals to I0 1 minus V by V0 whole square. They are asking that what will be the expression of V0 and root over I0 in terms of these statements. Do you understand the question at first? I hope yes. Okay, we will calculate, no problem. So first of all we need to check V0 and root over I0 will be how much, right? So how to do? In that options you can see they are asking about slope, they are asking about y-intercept. So first of all we need to check what will be the slope, what will be the y-intercept, right? Okay. I am going to write the expression here, I equals to I0 1 minus b by v0. I am not going to read these things right now. The options I am not going to read right now. When we will have the plot, then we can see the statement. I equals to I0 1 minus b by v0 whole square. Okay. I0 1 minus b by v0 whole square. Right? Okay. So they are asking to search I0 and V0. Basically root over I0 and V0. So what we will do? First of all, you can see this expression. So what I will do? First of all, root over I0. 1 minus V by V0. Simple. Now root over I equals to root over I0 minus root over I0 v by v0. Right? I can write like that. Okay. Then can I write this in this type? I can write like that also, right? So I can also write this. Yes, I can write that one, right? So what is basically this one? This one is if I plot y equals to mx plus c, then just we want to compare these two, y equals to mx plus c and root over I equals to minus root over I0 by v0 into v plus root over I0. So the plot will be between which to which? What will be y, what will be x? If I just compare these two with this one, then what will be the value of y and what will be the value of x? Can anyone tell me? Like if I write here y x, then y will be what? Then and x will be what? X will be v, y will be root over of I, right? So if I just calculate, if I just plot root over I versus v, then our m will be minus root over I0 divided by v0, correct? And our intercept c will be root over I0. Okay. Now we got the expression of v0 and root over I0. In that question they were asking that what will be the expression for v0 and I0. So I can have the answer from this. If I am writing here the plot between root over I and v, then the intercept will give us root over I0 value and the slope will give us minus root over I0 by v0 value. But
in question the x-axis v square is there.
X-axis?
X-axis v square plot is.
Acha, v square. No, yeah, I will tell you, no problem. You can see here also that I by v square is there, but root over I and v graph is also there, in option. Okay. So which one is the correct one, that we will tell, but we will just first reproduce ourselves the answer. Okay. So that parameters v0 and root over I0 can be graphically determined as how much. So what we have done till now, you can see here, I get the intercept as root over I0 directly, but I can't get v0 directly from the slope. You can see that the slope is minus root over I0 by v0. So it is not exactly v0, right? So now what I can do, let me write one thing. If I am going to write here this one, then what will be the value is? This will be v0, right? So what is this? This is nothing but minus of c divided by m. Right? C was root over I0. Minus of c means minus root over I0. M was minus root over I0 by v0. So minus c by m is v0. Do you understand the point? That means our root over I0 is coming from the intercept c directly, and the v0 is coming from the negative ratio of intercept and slope. when the plot will be between root over I and V. Is it clear? Is it clear?
Yes, ma'am.
Okay. Now just see the option here. Right now I will go to the statement each and every. You can see here the slope and the intercept of the I V square graph. That is not correct. The negative of the ratio of the y-intercept and the slope and the y-intercept of the I V square graph. That is also not correct. The slope and the y-intercept of the root I V graph. That is also not correct. Now focus on the D option. The negative of the ratio of the y-intercept and the slope, that will give us V0, and y-intercept, that will give us root over I0 of the root IV graph. That means our correct answer will be D. Okay? I hope it understandable. If you have any question, you just ask me. So for that case, what we need to check? We need to check the expression of V0 and root over I0 in terms of slope and intercept, y-intercept. Now we have already discovered the result. The result will be root over I0 is nothing but the y-intercept of the graph root IV, and the root over I0, the V0 will be the case if I take the ratio of minus C and M. Okay, I hope it's understandable. Now we will go to the next question. That is little bit very nice question actually. This little bit tricky as well as little bit very nice question. Okay, next I have taken that one from GATE NET 2015 December question paper. This is very simple question, but still let's see that. This is the question number 42. If the reverse bias voltage of a silicon reactor is increased by a factor of 2, the corresponding transition capacitance will vary at which proportion? Okay. So for that, I need to know one thing, one expression, so that it will be very much simple for all of you. Basically, in that question, they are asking that the relation between reverse bias voltage and transistor capacitance, right? So the relation between the transistor capacitance, let me write here transition capacitance and reverse bias voltage, let me write it as V. So the relation between CT and V is like CT is proportional to 1 by root V. Okay. Now in that question, just only this one we need to know. Otherwise we can totally understand the question fully. What is the question basically? The question is telling that the reverse voltage of a silicon reactor is increased by a factor of 2. If it is doing, then what will be the change in the transition capacitance? And I have the expression CT varies 1 by root over V. Now you have to tell me what will be the change in CT if I change the V by 2 units. You have to tell me. I will give you, let's say, 5 minutes, not 5 minutes, 3 minutes. I think you understand the question. The question is nothing but V is going to 2V, then what will be the change in CT? Will it be decreased by 2? Will it be increased by 2? Will it be decreased by root?
Increased by factor of root 2.
Increased by factor of root 2. Decreased by factor of root 2. Is everyone fine with that answer? If it is fine with that answer, then we'll calculate that one, or you can take some time also. Let me take you 1 minute so that you can have the answer clearly. I'm just writing here the expression. That will be proportional. So on 46 we will disclose the answer. 46 is done already. Okay, so first of all, if our voltage is increasing, then our CT will decrease or increase? It will decrease definitely, because it is inversely proportional. So it will be decreased. So I am going to cross that one and that one. Now decrease by which factor? You can see it is root V. So that means obviously decrease by root 2. That is the C answer, right? Okay. Okay, so now coming to the next question. Next question I have taken from CSIR NET 2015 June question paper, and the question is this one. Okay, let's see the question. Question number 40. The concentration of electrons N and holes P for an intrinsic semiconductor at a temperature T can be expressed as N equals to P equals to A T to the power 3 by 2 e to the power minus Eg by 2 kBt, where Eg is the band gap and A is a constant, if the mobility of both types of carriers is proportional to T to the power minus 3 by 2, then the log of the conductivity is a linear function of T inverse with slope how much? It's a little bit big in question, right? So we will break that in some step. First of all, they are asking that our N and P has a relation, this one, where Eg is the band gap and A is a constant, that is fine. Now they have already mentioned one more thing, that mobility of both types is proportional to T to the power minus 3 by 2, right? Then the log of the conductivity has a linear function of T inverse relation with the slope how much? Now first of all, the main thing we need to calculate what will be the conductivity here. Can you tell me what is the expression for conductivity? If it's like electrons, yeah, tell me.
N mu n plus P mu n.
N?
P mu n.
N mu n plus N mu?
N into
I can't hear you properly, but yeah, fine. See, basically, mobility is nothing but the multiplication of N. Let's say I am writing here. Okay, here you can see that the electrons and the protons, holes concentration are exactly same, right? So N, then mu n, right, plus P mu P. Oh, what happened? Arey. Can you see my screen? It is not visible, I think. I hope the screen is visible right now. Yes. Okay, so they are asking that what is there in that chat box? C. Okay. What is C? Okay, good, very good. So like here, so the sigma can be written as like the N and then let's say mobility mu N plus P mu P. So like I am just going to write the number only because it is not the 2, 3, 4. I am just going to have the expression of that sigma. So here you can see N, P, these are same actually, right? And also the mobility also very exactly same. Not exactly same, but it is saying that the mobility is proportional to T to the power minus 3 by 2. So if I write here only like A T to the power 3 by 2 e to the power minus Eg by 2 kBt, then mu is T to the power minus 3 by 2, right? So what will be the value of sigma here? Sigma will be, let's say A, Actually it is not exactly t to the minus 3 by 2. There is some constant also, b into t to the minus 3 by 2, let's say. So ab e to the power minus eg by 2 kbt, and you can see here t to the 3 by 2, t to the minus 3 by 2 will cancel out. So if I write here log, yes, if I write here log of sigma, then it will come as, let's say, log of AB plus minus EG by 2 kBT, right? So now you can see here, this is nothing but a constant value, and they have already told that log of sigma is a function of t to the power minus 1, and yes, it is the correct one, because you can see that t is in the denominator. So I can have the slope here as minus Eg by 2 kb. Okay, so the correct answer will be the C1, whatever it is given here. So for that case, we just need to write the conductivity expression, simply expression, no need to write here 2, 3, like how many N are there, how many P are there. We don't need to write these things. We just need to write the expression here. Then if I just write the expression, then we can get the value of that sigma, and from that sigma we can have the expression of log sigma. Log sigma will be nothing but minus Eg by 2 kBt plus log of AB. And log of AB can be a constant. Then we can see that T inverse, it is linearly proportional to the T inverse with the slope minus Eg by 2 kb. Okay, I think it's understandable. Now we will go to the next question. Is there any question? No. Is there no other question? There is no other question. So yeah, till now I can finish for today's session. If you have any question regarding these questions, you can ask me. But unfortunately, the previous questions, whatever we have written here, that one was totally erased. So when I will upload the PDF, at that time there will be no answer. So sorry for that, but I think that will be good for you, because you can practice that one by yourself. Okay, because you can see here there is no handwritten thing. Whatever I have written, that was totally gone. So maybe you can't see the answer also, but you can find by yourself. Okay, so till now I think in that today's class there is no that much important question to ask. If you have any question, you can ask me, or otherwise we will see in the next class. I have already prepared, I think 9 or 10 questions, maybe 9, I think. Yeah. So yeah, these were the little bit previous to previous year CSIR NET question papers. Okay, so if there is no other question, then we can move on to the next week. We will meet in the next week with different topic. Okay. Till now, bye bye. If you have any question, you can ask me, no problem. Among these questions, if you have any question, see all the things whatever we wrote today's session, it was totally gone.
Ma'am, can you take question from the field effect transistor?
Sorry?
Field effect transistor.
Acha, transistor. Okay.
Field effect transistor, ma'am. Field effect transistor. MOSFET.
Yeah, I understand. I mean, like C mode, that is the transistor, and MOSFET also is there. Actually, I thought to include that one, but I thought that due to the time constant, it will not be there. Okay, I can do one thing. When the electronics topic will come, at that time I will definitely do the transistor and the MOSFET part there specifically, because see, in that case what I did just like the error part, and then digital part little bit, and then what I did, I think that
transistor is okay, ma'am, but the
I understand. MOSFET, okay. And OPAM also I did not mention here. So OPAM is also there, right? So OPAM is also a very important thing for that any type of competitive exam. Like if it is a differentiator circuit, if it is a additive circuit, differentiated
And
circuit.
also the data converter can
DA to
analog.
analog to digital, digital to analog, these type of things. Yeah. Okay, and also that uh, multiplexer is also there. Then for two and decoder is
Counter
there.
register.
Encoder, decoder. This is also there. Yeah, obviously, in only 1 hour class we can't cover all the topics of electronics. That I understand. Okay, so we can do one thing. Yeah, so when the next electronics class will be there, I will definitely include these things like transistor. Basically most of the things we will see from the transistor, drain current, drain voltage, that MOSFET, FET. These things we will include. Okay, so that will be helpful, I think. So in that class, I just mentioned the digital part little bit and the error part little bit. So maybe that's why it stopped little bit early. But yeah, fine. And there is also the gate is also there, but gate is very much simple, right? You can definitely do that by yourself also. So yeah, I should mention the transistor part also here. Okay, I will do that in the next class. And this is the expression, simple the expression calculation and the nature of that plot. Okay, so yeah, anything else like I just want to note it down, that transistor part, transistor, MOSFET, FET, and then what was that? Ah, OPA,
Converters.
OPAM, and you told something?
Data converter, ma'am. Analog to digital,
Ha
digital
ha.
to analog converter.
Okay. DSC, ADC. Analog to digital, digital to analog, and then something else. Multiplexer.
Counter register.
Encoder, decoder. Okay, one more thing was there. JK flip flop was there.
Counter
SR.
register.
Sorry?
Counter register.
Counter register, yeah. There are so many things. Okay. Register. And I think you need that one also, that JK flip flop, SR flip flop. Then, okay. If it is fine for you people, then it is fine. Okay. So this topic we will cover in the next electronics class. Okay, fine. Yeah. Okay, so bye bye till now. We will meet in the next class. Okay, bye. Thank you. Stop recording.